All right, today we're going to do something really cool. We are taking a super common, kind of messy, everyday problem and turning it into a fully functional, full-stack application. We're going to build a bridge from financial chaos all the way to clear, actionable insight.
And it all starts with this, right? That feeling. You've got scattered notes, random receipts, and, that vague sense of dread when you check your bank account. This is the universal headache we're setting out to solve.
So first things first, we need to actually define the mission. We're not just writing code for the fun of it. We're tackling a real-world problem, a point of friction that I think almost everyone can relate to.
And here's that mission, laid out. We are building a tool that moves you from financial chaos to financial clarity. And the goal here isn't just to store a bunch of numbers. It's to create a system that actually tells you a story about your spending habits.
Okay, so you wouldn't build a house without a blueprint, right? It's the same thing here. Before we write a single line of code, we need to map out our full-stack blueprint. We have to choose our tech stack, basically the set of tools we're going to use to build this thing.
Now, what's really interesting here is that we're using what's called a decoupled architecture. Just think of it like a highly specialized team. FastAPI, that's our engine doing all the heavy lifting in the background. MySQL is the team's perfect memory, storing every single transaction. Streamlit is the friendly face, the part the user actually talks to. And Pydantic? Well, Pydantic is our security guard at the door.
And having that security guard is absolutely crucial. See, the core idea here is validation over correction. It is so much easier to reject bad data at the door, like a typo and a dollar amount, than it is to try and clean up a corrupted database later on. That's Pydantic's whole job. It's our first line of defense.
All right, with the blueprint set, let's head down to the engine room. It's time to connect our Python code to the database. This is where we're going to build the core logic for actually storing and retrieving all of our financial data. So this is the classic database handshake. You connect, you create this thing called a cursor to send your commands, you execute the query, and, this part is critical, you close everything down. Now, the risk of doing this manually, if your app crashes, you can accidentally leave connections open, and that leads to resource leaks. Not good.
And that brings us to the professional approach. Instead of manually opening and closing everything, we use a Python feature called a context manager. Think of it like an automatic gatekeeper. It guarantees that the connection gets closed even if something goes wrong. It's a really small change in the code that makes the entire application dramatically more stable.
Fetching individual records one by one is useful, but the real power comes from making the database do the math for you. We don't just want a long list of transactions. We want to know the total we spent on groceries or the average cost of dining out. That whole process is called aggregation.
And this right here is how we do it. This one simple SQL query is the foundation for every single chart and trend line in our entire application. All we're doing is telling the database, hey, group all my expenses by category, and then give me the total sum for each one. This is how we turn all that raw data into actual knowledge.
Okay, one last really critical security note here. Always use parameterized queries. This separates your SQL command from any data the user gives you, which makes it impossible for a malicious user to inject their own code. Seriously, this is non-negotiable for protecting your app.
Okay, so our engine is built and our data is secure, but right now it's just a bunch of code that only a developer can use. It's time to build the face of our application, the user interface.
And here's a pro tip. The secret to a great user interface isn't the code, it's the sketch. By just drawing a simple mock-up of where everything is going to go, we clarify exactly what data our backend needs to provide. This simple step can save you countless hours of rewriting code later.
This is where the magic happens. For anyone who's ever been intimidated by web development, Streamlit is basically a superpower. It lets you build these beautiful, interactive web apps using only the Python skills you already have. It's a total game changer for data folks.
And the development speed is just incredible. Hot reloading means any change you make to your code appears instantly in the browser. You can add interactive sliders, tables, and tabs with just a few lines of Python, which makes building a prototype an absolute breeze.
So, our app is built, and it looks great. But how do we make sure it stays that way? Well, the final step is adding a safety net. These are the professional practices that make software robust, easy to debug, and reproducible for anyone.
And here's a huge distinction. When something goes wrong in a live application, print statements are totally useless. Logging is the professional solution. It creates a detailed record of every important event, every error, every transaction. It's the difference between guessing what caused a bug and knowing exactly what caused it.
Next, we've got to test our work, and we use a two-layer approach. First, we'll manually check the API with a tool like Postman just to make sure it's returning the right data. Then, we use PyTest to automate tests for our functions, checking how they handle all the weird edge cases. This double check prevents that classic garbage in, garbage out problem.
And for the final bit of polish, a simple text file. This little requirements.txt file lists every single library your project depends on. It's the key to making your project reproducible, allowing anyone, a colleague, or even your future self to set up your project with just one command. This little detail is what separates a hobby project from a professional one.
You know, when it's all said and done, a project like this really reinforces a huge idea. Data engineering, all that work of building clean, reliable data pipelines, is the silent hero of the data world. You can have the most advanced AI model on the planet, but without a solid foundation, it's pretty much useless.
So, as you work on your next project, I want you to ask yourself this. What's the foundational, often overlooked component, the silent hero, that's going to make everything else possible?